All right, I'm going to get to the right page here. We are going to talk about simple probability. Now, most of you are kind of familiar with probability in a pretty, a very basic sense. So like if somebody says, what are the odds of this happening? Or what's the likelihood that, if you flip a coin, you're going to get a head or you're going to get a tail, or this is going to happen. A lot of you kind of understand that. So we're just going to kind of look at the basics of that. Most of this really honestly goes back to 7th grade. It's a couple things that are a little new and different, but most of this is 7th grade stuff. So let's take a look at it. We're going to introduce some terms to you. If you've seen them before, great. If you haven't, don't worry about it. They're not complicated. So probability, obviously, in other words, the likelihood something will happen. Sample space. What sample space is it's a list of all the possible outcomes of something. So if I say I'm going to roll a die, right, which is one die, a 6-sided die, my sample space would be the numbers 1, 2, 3, 4, 5, and 6. If I said I'm going to flip a coin, my sample space would be heads or tails. So things like that, right? This next one, this P notation, a lot of times they'll say, what's the probability of picking a heart out of a deck of cards, right? Or they'll say, what's the probability of rolling a 7 if I shake two dice, right? And then this complement thing, we're going to talk a little more about in a minute, but usually the easiest way to think of a complement is if you look at what is the likelihood that you will do something, and then what's the likelihood that you won't. That's the complement. And those two things together make up the entire sample space. And so we're going to kind of look at all that. All right, so let's just look at a couple problems. One coin is randomly selected from a jar containing 70 nickels, 100 dimes, 80 quarters, and 50 $1 coins. Find each probability. So the first one is the probability of picking a quarter. So the first thing we need to do is we need to figure out what the entire sample space is, like how many. So I'm going to go, well, we've got 70, we've got 100, we've got 80, and we've got 50. So those are all the different things I have. And if I add that up, this is 150 together. And then if you add 50, that's 200. So we have 300 coins all together, right? And so then the probability of taking a quarter, right, for number one, the probability of picking a quarter is always, probability is always the number of options that it could be, right? So there's 80, because there's 80 quarters, over the total number of outcomes, right? So the desired outcome over the total number of outcomes. So it's 80 out of 300. And then you would get rid of some zeros, right? And so you got 8 over 30, and then we can continue to simplify that down by dividing them both by 2, and you get a 4/15 probability, all right? And then the other ways you can write this, okay, is you can take a calculator and you can go 4 divided by 15, which I'm doing right now. And then you could say that also is approximately equal to 0.27, because it's 26 repeating, right? And then another way, or you could say, or about 27%. So 27% chance, and the percents usually kind of ring with people a little better. But I think 4 and 15, all these kind of make sense. All right, so let's look at 2. Probability of picking a dime. Well, same thing. There's 100 dimes, so that's the possibility. And then the total number of outcomes is 300. Okay, so if we get rid of our zeros, you have a 1 in 3 chance, all right, which is approximately, 3 repeating, right? Keeps going, or 33%. Okay, number 3. What's the probability of picking a quarter or a nickel? So if you're looking at a quarter or a nickel, you would say, well, I've got 80 quarters and there's 70 nickels. So there's 150 possibilities out of 300 that would be 1 and 2, right? Because you get 15 over 30. And that is equal to 0.5 or 50%. All right, for a value greater than 10 cents, well, that would be the quarters or the $1 coins, right? So that would be 130 out of 300. Get rid of a 0, 13 out of 30. And then you could figure out what those decimals are. We won't do that. So I think you're getting the idea here. It's the possibilities over the total number of outcomes, right? So let's look at some other facets of this. All right, so one of the polygons below is chosen at random. Find each probability. So there are 6 polygons altogether, right? It looks like we've got a quadrilateral here and a quadrilateral here. We've got a triangle here, and a triangle here. And then we've got a 5-sided shape here that's kind of its own thing. All right, so 7. What is the probability of getting a triangle? Well, the probability of getting a triangle is there's 3 possibilities that it could be a triangle, right? Out of a total of 6 possibilities. All right, so 3 out of 6 simplifies to 1 out of 2, and then that would be 0.5 or 50%. All right, 8, probability of pentagon. Well, there's only one pentagon, and that's this guy right here, right? So 1 in 6, and that is, I believe, 0.16 repeating, or we'll say 17% about. Now this is where we talk about complements. It says probability of not a quadrilateral. Whenever you see not, what you should do is find out what is it for that thing. So let's find out what the probability of a quadrilateral is, and then not would be basically the balance of the rest of the set. So if we've got one quadrilateral here and one quadrilateral here, the probability of a quadrilateral would be 2 out of 6. So the complement of that would be, what's the balance to make that 6 out of 6? Well, it would be the things that it couldn't be, so it would be 4 out of 6. So in other words, 4 out of 6 items do not qualify for that. So 9 is 4 out of 6, which simplifies to 2/3, which is 66%. All right, and then 10 is the probability of more than 2 right angles. All right, so more than 2 right angles, that would pretty much just be this one and this one. So 2 out of 6, which becomes 1/3, which is, again, 33% or 0.33. All right, so I hope this is kind of making sense. It's not complicated, kind of common sense. The next video, we're going to talk about tree diagrams, so stick around.